Welcome. Today we're delving into a transformative approach to quantitative analysis in the jobs to be done methodology. Whether you're a seasoned jobs to be done practitioner or someone exploring the field, this is for you. In the traditional jobs to be done model, job executors rate outcomes and complexity factors as a part of a survey. These ratings help us identify areas of opportunity by analyzing their importance, satisfaction, and the challenges of achieving them. But today we're discussing something groundbreaking, a shift from survey-dependent data to simulation-driven insights. Imagine replacing scenario-based models with an agentic system capable of simulating every possible combination of situational factors and contexts. It's ambitious, but as you'll see, it's achievable. Let's start with what we already know. In traditional jobs to be done surveys, job executors rate desired outcomes by their importance, how critical the outcome is, and its satisfaction, how well current solutions meet that need. They also rate complexity factors, elements like experience level, budget, or technological limitations that influence their ability to succeed. These factors aren't new. They've always played a vital role in analysis. However, the insights they generate often come after the fact, analyzed for correlation with needs-based segments. While useful, this approach has limitations. It relies heavily on real survey responses, which are time-consuming and costly to gather. It struggles to predict how new solutions or scenarios will influence complexity factors and outcomes. And it lacks the capacity to explore emergent behaviors, those unpredictable dynamics that arise from situational factors interacting in unexpected ways. That's where our new approach comes in. Imagine a world where we could simulate every possible combination of situational factors and contexts to create highly detailed personas. Each persona represents a job executor, a virtual agent, with their unique constraints, attitudes, and environmental influences. This is not science fiction. By leveraging AI and agent-based modeling, we can move from static surveys to dynamic simulations. Here's how. At the heart of this approach are agentic models, virtual representations of job executors. Each agent is a rich, multidimensional persona that embodies situational and contextual factors, which we now build up front instead of discovering post-analysis. Let's break this down. Complexity factors include time constraints, budget limitations, environmental conditions, and organizational policies. These factors, rated on scales, act as the foundation for building personas. Contexts include the executor's industry, role, and organizational setting. For instance, a healthcare administrator faces vastly different constraints than a freelance graphic designer. A small business owner prioritizes cost effectiveness, while an enterprise manager values integration. Personas combine these factors and contexts into unique profiles. They represent every conceivable scenario a job executor might face. Example personas. Sarah Startup. She's budget conscious, tech savvy, and time strapped. Enterprise Eric. Focused on compliance with significant resources but complex organizational constraints. But there would be thousands of them, perhaps tens of thousands. And they would not be driven by demographics. Now that we have our agents, we can embed them into a simulation framework. This involves three critical components. The first would be a system dynamics model. This model captures feedback loops and relationships between outcomes, complexity factors, and agent behaviors. For instance, introducing a new solution might initially reduce complexity, increasing satisfaction. Over time, however, it could create new challenges, like interoperability issues. The next component would be agent-based simulation. Each agent evaluates outcomes based on their unique profile, situational factors, and the solutions available. They rate importance and satisfaction dynamically, responding to changing environments, and interact with other agents, creating network effects such as collective adoption or rejection of a solution. And the final component would be emergent behaviors. By running the simulation, we can observe patterns that traditional models can't capture, such as how new complexity factors arise when a solution reaches critical adoption levels, and how situational constraints lead to unexpected correlations between outcomes and satisfaction. Here's how the simulation works step by step. The first step is initialization. We assign attributes to agents: role, context, situational constraints. We define starting conditions, initial complexity factors, and satisfaction levels. The next step is iterative simulation. Agents react to their environment in time steps, such as months or quarters. New solutions are introduced, triggering shifts in complexity factors. Agents update their ratings dynamically, influencing system-wide metrics. And finally, we have data collection and analysis. We track how satisfaction, importance, and complexity evolve over time, and we identify which solutions reduce complexity and which introduce new challenges. AI is the backbone of this system. Here's why. Agent decision-making. AI models simulate how agents make decisions, adapt to changes, and evaluate solutions. Dynamic adaptation. Machine learning identifies new complexity factors as they emerge, enriching the simulation. Scalability. AI enables simulations with thousands of agents, representing a diverse population of job executors. This approach offers unparalleled insights, such as predicting how new solutions will impact complexity and satisfaction, identifying high-priority need segments based on simulated personas, and testing what-if scenarios to evaluate future market opportunities. Imagine using this model to design solutions for industries with tight regulations like healthcare, or rapidly changing environments like tech startups. The possibilities are endless. To recap, this innovative approach replaces traditional surveys with a robust simulation framework powered by agentic models and system dynamics. By simulating situational factors and contexts up front, we gain richer, more actionable insights into how complexity factors shape job execution. This is the future of jobs to be done quantitative analysis: dynamic, predictive, and scalable. Thank you for watching. If these ideas resonate with you and you're excited about their potential, don't keep them to yourself. Like and share this video to help spread the word. And if you'd like to dive deeper or get involved, I'd love to hear from you. Reach out to me directly, and let's explore how we can make this vision a reality together. See you next time.